All right, today we're going to break down a brand new algorithm that's seriously shaking up how the world's most powerful AI models get trained. We are diving into a paper on something called Group Sequence Policy Optimization, or GSPO for short. And trust me, it tackles a problem that can cost millions of dollars.
Now, what if I told you that the very act of training a massive AI could cause it to just catastrophically fail? This is not science fiction. It is a very real, multi-million-dollar problem that the biggest AI labs in the world are racing to solve. Imagine spending weeks, a fortune in computing power, only for the entire model to just break, irreversibly. So, to really get why this new solution is such a big deal, we've got to first understand the problem it's solving. And this is all about what happens when we're pushing the absolute boundaries of what AI can do. At the heart of all this is a technique you've probably heard of, reinforcement learning, or RL. It's basically how we teach an AI to develop deep reasoning skills. It learns by trial and error. It tries something, gets a reward if it did a good job, and learns from that. But this incredibly powerful method has a really dangerous flaw. You see, as we keep pushing for these models to be smarter and more capable, the actual training process gets super fragile. It becomes unstable. And that instability puts the entire massive investment of time, money, and resources at risk. And that risk has a name: model collapse. And yeah, it's as bad as it sounds. It's a sudden, catastrophic failure where the model's performance just takes a nosedive. The paper points out that when this happens, you can't even just roll back to an earlier save point. The whole training run is a complete and total loss.
So what's causing this? Why does this collapse even happen? What's the gremlin in the machine, right? Well, the answer lies in how the older algorithms looked at the data, specifically how they obsessed over every single individual word, or what we call a token.
It really all boils down to a fundamental difference in approach. The old way, the previous state-of-the-art called GRPO, was like judging an essay by grading every single word. As you can imagine, that creates a lot of noise. The new way, GSPO, judges the entire essay all at once, and that provides a clear, stable learning signal.
To really nail this down, just picture you're a teacher, and you have to grade a 1,000-word essay. The old method, GRPO, is like taking out a magnifying glass and giving a separate score to every single word. It's this completely microscopic and frankly chaotic way to evaluate the work.
So what's the result of grading every single word? You get what the paper calls high-variance noise. It's like a storm of chaotic, conflicting signals that just builds and builds, especially in long, complex answers. The algorithm amplifies this noise until, eventually, the whole system just gives up and collapses.
Okay, so that's the problem. Now for the aha moment. This is where GSPO comes in with a beautifully simple shift in perspective that fixes this whole mess. Instead of grading word by word, GSPO does what any sane teacher would do. It grades the entire essay at once. It looks at the whole sequence of words, the whole response, to understand its overall quality and meaning. It's more natural, and as it turns out, way more stable.
And this brings us right to the core principle of GSPO, and it's so illogical when you hear it. The way you optimize the model should match the way you reward it. If you're giving a reward for the entire response, then the learning process itself has to happen on the entire response. It's such a simple but powerful idea, and it aligns everything perfectly, getting rid of all that noise that plagued the older methods.
Okay, the theory sounds great, right? It's elegant, but does it actually work in the real world? Well, the results are kinda staggering. Let's look at the proof.
I mean, look at this. The data from the paper shows GSPO isn't just a little better, it's better across the board. It's more efficient, getting better results with the same amount of training. It allows for stable, long-term training without that dreaded collapse. And at the end of the day, it just produces models that perform better on some really tough benchmarks.
But here's where things get really wild. The research uncovered something completely counterintuitive, a real paradox in how GSPO actually handles the data it's learning from.
Just look at this chart. It shows how much data each algorithm clips, that is, just flat out ignores during training. The old method, GRPO, barely ignores anything. But GSPO, it throws away over 100 times more data. That's insane.
So wait, how on earth does it learn better by ignoring more data? Well, it turns out that by being so aggressive, GSPO is actually doing some brilliant quality control. It's throwing out all that noisy, low-quality, token-level data we were just talking about, which forces the model to focus only on the most reliable and effective learning signals.
And this new approach also solves another massive headache in the AI world, training these things called mixture of experts models, or MOEs. You can think of these as having a whole team of specialized experts inside the AI, which makes them super powerful, but also notoriously unstable to train.
See, with the old GRPO method, these Mo models were just chaotic. After every tiny little training update, the model would suddenly switch which internal experts it was using for the very same task. The paper calls this expert activation volatility, and this constant shuffling just completely confused the learning process.
And this is where GSPO is just a total game changer, because it's looking at the final essay, the whole sequence. It doesn't get distracted by all that frantic shuffling going on inside. It completely solves the instability problem and lets us unlock the full power of these models, all without needing complicated and expensive workarounds.
Okay, so a new, stable algorithm. What does this really mean for the future of AI? What are the bigger takeaways here?
Well, for starters, this isn't just some lab experiment. The researchers say GSPO is part of the secret sauce that's making the latest QN3 models so good. It also has the potential to simplify the incredibly complex systems needed for training, but most importantly, it provides a stable foundation to just keep scaling up AI capabilities.
And that's exactly how the creators of this algorithm see its future. They said, "We envision GSPO as a robust and scalable algorithmic foundation that will enable the continued advancement of large-scale RL training with language models." They see it as the bedrock for what's next.
You know, by making AI training less like a risky game of Jenga and more like building a solid skyscraper, GSPO has really just opened the floodgates for scaling. So the real question now isn't if we can build bigger, more powerful models, but rather what new frontiers of intelligence are they going to conquer next?